and innovation-led machine tool technologies. With over 500 member companies today, IMTMA members encompass over 90% of the organized machine tools and accessories business in India. IMTMA has been creating a vibrant, interactive space for shared innovations in the industry through support to its member companies, organizing of mega events and flagship trade exhibitions at its advanced BIEC exhibition premises and contributing to government regulations. What's more, IMTMA has today become a center of excellence for focused application-based training. Training and skill development at IMTMA. The IMTMA Training Advantage. The IMTMA courses are differentiated by the comprehensive hands-on experience that the students receive on the latest machines that are in current use in leading organizations across the world. The finishing school, the automation course and design course are supported by practical training on CNC machines and other equipment, giving the students a direct edge over the average theory-based engineering applicants. Engineering students gain confidence in their skills and prospective roles and gain campus advantage to the powerful member organizations who are part of the IMTMA network. Short-term workshops for industry professionals.
We conduct many short-term programs at IMTMA for working professionals. We organize such workshops, more than 80 technical topics covering the various functions of manufacturing industries, including R&D, productions, planning, quality, and maintenance. Each of these programs are delivered by the subject matter expert having more than 30 years of experience in the particular domains. Classroom sessions are supported by practicals, demonstration, and industry visit in order to make the learning complete.
Trade exhibitions at IMTMA. The IMTMA exhibitions and trade shows have been fertile grounds for B2B and B2C business networking, providing the ideal showcase for members to demonstrate to an international machining industry. IMTMA has taken great strides in its vision for a unified, progressive machine tool industry in India. IMTMA continues to provide next-generation training and skill development to young engineering minds who will go on to reshape the Indian industrial landscape as we know it.
So participants, this was a short video which explained you about the IMTMA activities. Now I would invite Ramesh sir.
Yes, just a minute. Let me just share my website. Let me just share my PPT. Just a minute. Okay, just give me a moment. I'm setting it up.
Yeah.
Maybe you'll have to just a minute. Maybe you'll have to set it up, Dhananjay, yourself. Just a minute. I think you will have to set it up, Dhananjay, yourself. Please bear with me. Not able to
Yeah,
share.
fine, sir. Yeah. Yeah. So participants, a quick reminder, as we are passing through COVID scenario, please use face masks, maintain social distancing, wash your hands regularly, monitor your temperature regularly, and if necessary, visit your doctor. We'll briefly explain you about IMTMA. As you have seen in the video, IMTMA is mainly into training, exhibitions, and mega events. Imtex is one of the well-known brands. It is Asia's largest machine tool exhibition, held every year in Bangalore. So about IMTMA training, we offer 200 plus training programs. We have imparted training for more than 32,000 professionals from more than 4,500 companies, and mandates 126,000. These are the snapshots of our technology centers from Bangalore and Pune, wherein we provide state-of-art technical inputs to machine tool builders and users. We have Industry 4 ready labs, automation lab with robots. We conduct short-term programs and long-term programs. Short-term programs are mainly for professionals, and long-term programs are for practicing engineers and fresh engineers. These are the career-oriented programs. And another vertical which we have is e-learning. So I will explain you in further slides. So our classroom trainings is a blend of theory and hands-on training, and wherever necessary, we organize industry visits. E-learning, that is IMTMA elearn.in, is our separate vertical. E-learning can be accessed for 30 days after purchasing the license. Courses can be accessed 24/7 as per the convenience, and these are quite reasonably priced. About the online training programs, we have conducted more than 300 online training programs, and more than 15,000 people participated in the same. These are quite budget-friendly training programs, enabled and these are enabled with question and answers, pollings, chat box to make them more interactive. And long-term training programs, as I said, these are mainly for fresh engineers and practicing engineers. These are career-oriented programs. So our main websites, imtmaelearn.in and imtmatraining.com. On both these websites, you can explore training programs of your interest. And if you want to know more about IMTMA, you can visit imtma.in. So this was all about IMTMA. I'll stop sharing now.
Okay, Dhananjay, thanks. Let me just introduce the speaker for the day. The speaker for the day is Mr. Abhishek Kalra. Abhishek Kalra is currently working as Associate Vice President, Application Consultancy at Altem Technologies, and he oversees the application engineering, product management, and pre-sales operations for digital manufacturing and digitization business at Altem. And by profession, he's a graduate in electrical and electronics engineering from Uttar Pradesh Technical University, and he started his career with additive manufacturing solutions in South Africa. Subsequently, he moved to the role of a solution specialist, overseeing various 3D printing and reverse engineering solutions requirements. And he was also responsible for channel management for the South African and Sub-Saharan African resellers. And in 2017, he came back to India and has since been leading countrywide operations for digital manufacturing activities at Altem Technologies. And he has conducted a number of technical consultancy projects with clients of various countries in South Africa, India, Saudi Arabia, and Namibia. And of course, today he's here to take us through this webinar and provide you with more information on how you could benefit from these additive manufacturing solutions. Over to Abhishek.
Thank you so much, Mr. Ramesh and Mr. Dhananjay. Good afternoon to everybody. Uh, One second. Okay, I hope you are able to see my screen, right?
Yeah. Yes.
Visible.
Lovely, lovely. So first of all, are
Is
you
it in
able to see
video
the
mode?
full screen?
Yeah, yeah. But
Are you?
is it in video mode? Because it was looking hazy a bit. You can just check. You can click more at
Is
the
it?
header.
One second. You see the screen now?
Yeah, yeah.
Okay,
Yes.
lovely. So, good afternoon to one and all, and thank you so much for joining today's session. As introduced, I am Abhishek Kalra, and I lead the digital manufacturing and digitization business, 3D technologies business for Altem Technologies. Today, we're going to talk about a very interesting subject, as you can see on the screen, is how to successfully build extremely large and complex parts in a click of a button without having to do any sort of tooling, without having to do any sort of master preparation, and at a fraction of the cost as compared to alternative methods. Before I continue, I must ensure and I hope that all of you, your family members, colleagues, and everybody else is safe. And I hope that you continue to remain safe going forward. And I hope we get through this pandemic shortly. Now, we're gonna talk before we go further. We're gonna talk about some of the important issues faced by the manufacturing industry today. We're gonna talk about importance of design validation and prototyping and how it relates to the important issues faced by manufacturing industry. What are some of the challenges with conventional methods of design validation, and how does 3D printing and fused deposition modeling, specifically this new large format 3D printer that we have launched, help solve all of the above? Before we go further, a little bit about ourselves. Altem Technologies started in 2011. We are in the 10th year of our operation. Could have been a merrier time for us, but nevertheless, uh, essentially we call ourselves as a 3D innovation platform solutions provider. What that means is that we want to and we are capable to address every and any problem of any company organization trying to create a successful product which will eventually be manufactured. We enable companies to go from idea to reality, from art to part, as I like to call it. And in that pursuit, we have partnered with some of the top global solution providers of the world, starting from Dassault Systems, which I'm sure most of you know for their CAD platforms, uh, the most popular one being Katia. We also have simulation analysis solutions. So once a product is designed, before you get into manufacturing, you need to make sure that it runs under all possible conditions that the part will be susceptible to. For example, a car has to run on smooth roads, on dirty roads, on off roads. It has to run in day, it has to run in night, under normal weather, heavy weather, so on and so forth. So simulation and analysis solutions help you predict the behavior of your component under various solutions, under various conditions. And then we come to the heart of our business solution, which is rapid prototyping and 3D digitization. Most of today's presentation will be based on that. And we also have solutions in life sciences. So the same story of from idea to product for life sciencing and drug discovery, but that's a topic for another day. As we said, we started in 2011, and today, after 10 years, we have been conferred with a lot of different awards, starting from we are in the top 100 MSME companies of India. We've been awarded as the most innovative 3D printing company of India by Frost and Sullivan, and we have one of the largest and the most happiest install base among all Stratasys partners across the world. So that's something that we are very proud of, that our customers are very happy with our support. We have more than 400 customers in different areas, ranging from automotive to aerospace, to consumer products, to healthcare companies, to packaging companies, so on and so forth. And the good thing about 3D printing is that it is a solution that impacts everybody and anybody. whether you are a plastic bottle manufacturer or a four-wheeler manufacturer or a two-wheeler manufacturer or Airbus that makes plane or a ISRO that makes satellites. It impacts everybody because it's becoming more and more critical for everybody to improve their products and reduce the time and cost in which these products are made. Now let's look at some of the issues that manufacturing driven industries face. Now, I'm assuming that most of you are from the manufacturing industry, so this will be highly relatable to you. But still, first thing is customer expectations have become very, very high. We are customers ourselves, and we want the best products, not just functionally, but also aesthetically. When you go buy a car, you look at the function, how big is the engine, what is the mileage, all of that a bit later. But you are also equally interested in what is the appeal of the car. Nobody wants to buy a Fiat today. People want to buy a Mercedes today. Uh, if I say that a Fiat car and let's not go to Mercedes, but let's say a Maruti Baleno have the same functional performance, you will never still go and buy a Fiat. You'll still go and buy a Maruti Baleno. Even if the functional performance of the Fiat is a little bit higher, you'll still go ahead and buy a Baleno, even if it's a little more higher at price. But while customers want better products, they simultaneously want them at the lower cost. And competition will always be able to deliver products at the lower cost unless you are the fastest, most efficient, and the cheapest. This is perhaps an image that all of you would have seen. This is an example from the smartphone industry, but is applicable to anybody and everybody, whether it be consumer electronics, whether it be automotive, whether it be uh, special purpose machinery. Competition is so tight that the average time that companies have to launch their product is reducing drastically. 3, 4, 5 years ago, 7 years ago, it used to take a car company easily 1.5 to 2 years to launch a new model. Now we have come into the scenario, and even the pandemic has not slowed it down, where automotive companies are launching 2, 3, 4 products every year, right? And then immediately another car company will launch another product. So in order to be able to sell more, your product has to be the best product that is available in the market at the best cost that is the worth of that product, and it has to be most exciting for the customer. The third problem is cost pressure. People want better products. You have a larger competition to deal with. People want better products at a lower cost. You have to innovate faster, but there's always a consistent cost pressure that I need to do all of my development, but at the lowest possible cost. And this has been accelerated by COVID. So today, if I'm not efficient, if I don't consume my resources properly, if I don't plan my projects properly, then the cost pressure coupled with high customer expectations and competition is going to kill my product. Then confidentiality becomes a very important thing here. There are several companies, General Motors, to give one example, who've had to almost scrap the entire product because of data breaches. Now, what happens is, because you are faced with such high competition and cost pressure, what we tend to do is we tend to not invest in technologies in-house and start to outsource work. Some places it works. I'm not saying outsourcing is bad, but often that outsourcing is driven by a risk of your data and your project going to the same vendor as your competition's vendor. I have an interesting anecdote to share with you from a few days back. One of my customers required a very, very large part, and this was for a new automotive product development that they wanted to do, and they outsourced it to a services company, not based in India. At least I can say that proudly. And of course, all NDAs were signed and all confidentiality agreements were in place. But then what happened is 2 days later, the image of that product, which is a styling component for a car, for a four-wheeler, is being published on LinkedIn. And so despite non-disclosures, data does get leaked, and it's very relevant, very important that your product is unique. So if confidentiality is not guaranteed and your data is getting leaked left, right, and center, there is no way that you can be unique. And the fifth problem or window of opportunity, how would you like to consider it, is that we need to increase automation, right? we need reliable lights out, if not completely lights out, at least remote controlled manufacturing processes. COVID has taught us a big lesson over here, is that anytime anything could happen, people could fall sick, factories would need to be shut down, labor needs to be removed, governments could put lockdown, but manufacturing still needs to be done. I think we are far away from complete automation, but tools like 3D printing and some of the other Industry 4.0 tools that even Ramesh and Dhananjay were mentioning in their presentation are really, really important for every manufacturing driven organization to adopt if we want to consolidate and create the best product at the best price. And the most important thing is change is necessary. It's no longer option, it's no longer a luxury. It is necessary. We need to evolve. Manufacturing industries are under the constant pressure to improve and change to create the best possible product. So these criticalities uh, lead to uh, a force that would require you to invest in advanced technologies, which might cost you some money to start with, but will definitely give you uh, the solution to all of these problems, if not in a short run, at least in a medium to long run. Let's look at how that's going to happen. Now, all of you, I'm assuming, are product development people. For those of you on the call who are not product development people, this is how a product development works. So let's say I want to create a bottle of perfume, or, for example, or let's say air conditioner. It starts with an idea. Then you get into development where you design the product, design the systems that go around the product. So for example, let me give you a very simple example. I have this plastic bottle in my hand. This has two components, the bottle itself and the cap. So my development stage would be where I design the bottle in a 3D three-dimensional drawing software, um, and then choose the material, choose the color, those kind of things. And then I need to test and validate my design, which typically happens with either prototyping solutions or simulation solutions. Once you've crossed this path and step the foot forward towards manufacturing, your fate is sealed. The moment tool, and you guys are machining people, so none of you are better judges. Once your tool preparation in your pre-production starts, there's not really any major changes that you can make to the concept of the product itself. You can, but then you'll have to go back and then waste time and waste money. Now, here is where you have scope of product improvement. This is the place where you can improve to your product until you get the best possible product. But then the challenge is that if we keep doing iterations, or if the cost of iterations and the lead time of iterations is so high, then somewhere we have to put our foot down and say no. This is what the best I can do, and then I leave the rest to my best sense of judgment or to the fate. And of course, you have improvement, a scope of improvement, principally from a product cost reduction point in the manufacturing cycle as well. But that does not improve the quality of your product. So when I say scope of product improvement, I have one simple funda: fail fast, succeed fast. You fail fast, only then can you succeed fast. So if in the on the second day of me coming up with an idea, I know that there are errors. For example, the cap doesn't fit to the bottle properly. I can immediately correct it and then move faster towards my production and tool preparation cost. And the second version of fail fast, succeed fast is to achieve the best possible version of your product. Again, the Fiat and Baleno story. Today, Maruti itself, I'll give Maruti as an example because I'm sure most of us have driven Maruti cars at least once in our lifetimes. Maruti has some immensely popular cars, Baleno, Ciaz, so on and so forth, uh, SX4 and Alto, for example. But it also has some cars which nobody wants to buy. Uh, 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 Celerio is one example. There are several other. I'll not take specific brand names. So, if you are not able to create the best possible version of your product, there are high likely chances that somebody else will, and then your product will be not considered over competition's product. But this is only possible to do all the possible iterations and to explore all possible creativities when there is a fast and cheap method to develop, test, and validate your product. And then, of course, in with respect to manufacturing, you have to reduce vendor costs, reduce logistics costs, set up rate contracts, so on and so forth. but you also need to improve factory floor efficiencies. How fast are products rolling out of my factory? How how efficient is my labor? These three places are places where 3D printing and prototyping can fit perfectly and give you incrementally faster results. Let's look at it how. Now, 3D printing is not new. It has been around for at least the past 35 years. Uh, Today, I don't think there is anybody in the country and of course in the world who is not using 3D printing in one way or the other. Whether you are a small bottle and cap manufacturer or an airplane manufacturer, everybody is using some sort of 3D printing uh, in some way or the other, whether they have in-house machines or they outsource it to vendors, or at least that if they don't do 3D printing, they would do some sort of rapid prototyping with machining and soft tooling, etc., which are somehow also linked to the same idea that I'm trying to present. Now, the traditional way of prototyping is conventional manufacturing, combination of machining and tooling. Now, I don't need to tell you how complex it is to create, especially very complex prototypes like the one that you see on the screen with machining and molding. It's labor intensive, it's a multi stage process. You might require multiple machining cycles, multiple tools. That obviously gets associated with high lead time. Costs are very high. Lead time can go into weeks. And if something goes wrong, even if your design is out by a millimeter, either you throw money to repair your tool or you throw money to start all over. Long story short, you spend a lot of time, you spend a lot of money. This kind of gets solved with 3D printing, but the challenge is that traditionally 3D printing has been very unaffordable. Um, well, of course, you have smaller printers which cost as low as 5 lakh rupees, 6 lakh rupees, some even cheaper, but they are very low quality, so we're not going to talk about it. But if you talk about big parts, larger parts, complete fender of cars or complete panel of washing machines or complete cooktop of a gas stove, white goods, HVACs, so on and so forth, to be able for to be able to invest for every company in such large big format 3D printers is impossible, because traditionally that type of machines have gone into crores and crores of cost. So what people do is they tend to go outsourcing. There are some very good service bureaus that are set up in the country. We are obviously one of them, where you give your part and they give you your you give your design and they give you your part back, and they typically take a week to 10 days depending upon how big the part is. Now there are several challenges. Again, you need to be cost competitive. So what's going to happen is that your engineers or your product heads are going to call 4 or 5 vendors, send the files to 4 or 5 different people. If you have non-confidentiality with those 4 or 5 people, good enough. If not, then you have to sign confidentiality agreements. It's a very tedious process. Then there is no control. If my machine as a service bureau fails, then your product development as an end customer has stopped, and there's nothing that you can do about it. Of course, the lead time is higher, and most importantly, confidentiality is at risk. I told you, one of my customers got a part done from a fairly popular, in fact, globally listed service bureau under a confidentiality agreement, and they shared their part image on LinkedIn in the next day. Now, this is very simple. I have been to scenarios where I have seen images of other customers' parts on service bureau's website, and it could be honest mistake, but it does happen. And in fact, even that, because those service bureaus have to amortize the cost of the heavy equipment that they have bought, they'll charge you at least 2x 3x of time. So your lead time is still high, lower than conventional manufacturing, of course, because 3D printing is faster and cheaper. But because you're paying for somebody else's time and somebody else's money, you still end up paying 2 to 3 times what it would cost idealistically. The next thing which people do, which is, I mean, I would call it a brutal mistake, is to try and use non-reliable in-house 3D printing. Now, 3D printing is well, such a heavily talked about topic that people feel that a 5 lakh rupee 3D printer and a 1 crore rupee 3D printer and a 10 lakh rupee 3D printer is the same. And what happens is that people buy machines without properly evaluating what their requirements are. I have seen customers who produce 3 meters part, buy a 300 by 300 mm machine, and they're splitting the part, joining it together. parts fail, there are reliability issues. When you assemble the whole thing together, the deviations of accuracies of 10 different parts that you're trying to join together have added up, and the overall assembly that you get after 2 weeks or 3 weeks of hard effort is not usable because the part is inaccurate, right? So this is a complete no-no. So what is the solution then? The solution is to have a large format industrial 3D printer, which gives you exceptional part quality. When I say part quality, I just don't mean a fancy looking surface finish, but I mean 100% accurate geometry realization of whatever you'd like to feed into it, whether it be a simple cube or a complex air hood vent like this, or any geometry that you can design. Because when you design products, you don't design it according to 3D printing, you design it according to your final mass manufacturing method. So your prototype has to copy or mimic that. uh, these systems are typically plug and play, they are laborless, they are generally reliable and error free, and there is, even if you fail, so you start a job today and it's a 30-hour job, at the end of 30 hours you know whether your idea or your design is correct or not, and then you can iterate faster. As I say, fail fast, succeed fast. But there's one problem. The challenge is cost. Conventionally large 3D printers, and when I say large 3D printers, I mean printers to the tune of 1 meter by 1 meter bed size or half meter by half meter bed size, have been expensive. There are cheaper systems available in the market, for crying out loud. The other day, I got an email from somebody who was selling a 1 meter by 1 meter by 1 meter and claiming it to be industrial for 5 lakh rupees. And I can guarantee you that you cannot even take out one single successful part out of that 5 lakh rupees supposedly industrial machine. So I'm not even going to talk about those are sham. When I talk about proper well-built industrial machines, whether it be from Stratasys, which I represent, or some other companies, they get into crores. Like, you have to pay very high capex. Operations are difficult because these are big industrial systems. Now, for cash-rich companies like the Boeings and the Airbus of the world, and for governments like the ISROs or the HALs, this is okay. They can dedicate government fund to it. But for smaller companies, for companies with the cost pressure that we spoke about in the early part of the presentation, this is almost impossible. And then you get into the loop of compromise. So now, how do we solve this problem? And this is the problem that we as 3D printing vendors are being facing from the past 10 years, is that people want big parts, but the operating cost and the capex cost is so high that people end up looking at alternatives, and then things just fall apart. So how do we do it? So we introduced to you a revolutionary product which is based on the same industrial 3D printers that we've been developing and selling for 30 years at a much lower price point. I'm going to play a video. If somebody can just put it on the chat, if you can hear the sound or not. So are you able to hear the audio?
Yeah, audible, sir.
the video gives you a bit of a hint on what is the scale of things that I'm talking about. Long story short, we have developed an industrial 3D printer on the same DNA as our larger previous generation industrial 3D printers, but you get it at a price that does not break the bank. Now, is it as cheap as a 5 lakh, 10 lakh rupee machine? No, it's still higher at a cost. But if you're a company that does a lot of large size parts, and I'm sure then you're currently struggling with a large cost of outsourcing or large lead time of outsourcing, then this machine is for you. Uh, I'm not going to get too much into the features of the machine because that is irrelevant. A couple of things that I'd like to tell you is that we have the largest industrial 3D printing size available in the global market. There's no industrial machine. Of course, the definition of industrial machine could vary between people to people, but anyway, which has a 1 meter, one meter bed size. So very rarely will you have a need to actually split your parts, which is where the trouble starts. As you saw in the video, you can produce some very complex geometries, parts which have internal channels, parts which are overall very large parts but have very thin features, parts where you require 100 micron accuracy or 50 micron accuracy over a 700 or 800 part, and at a much faster lead time and much or significantly lower cost than any other possible equivalent quality in alternatives that are available. Let's take an example. Now, this part that you see in the gentleman's hand is a hood vent for a four vehicle. This is how the part goes. So this part gets installed from beneath the car, just under the hood or the bonnet of the car, and the fins come out, which act as air release mechanism. So this is not just a form and fit prototype, but this is a part where it will be susceptible to a lot of endurances and a lot of thermal loads because the engine will release some heat. It's a 783 mm, so almost 800 mm part, but it has very thin and complex curvatures. The fins are what controls the aerodynamics, and these fins are less than 5 mm. All of this has to be produced in a sub 100 micron accuracy and susceptible to thermal loads. Now, we ran an analysis, and we ran this analysis locally in India, where if you have an in-house machine, it costs you about 4 days and about 80,000 rupees of cost. And when I say 80,000 rupees of cost, this is not just 80,000 rupees of material cost. This is everything: labor, spare parts, accessories, power, everything put together, time cost, internal time cost to 80,000 rupees. And if we outsource it to service bureau, irrespective of technology, you'll have at least double the time and double the cost. Why double the time and double the cost? Because service bureaus, even if they are able to do the part at that particular price, they charge you more because they have to amortize their machine, right? Which is, there's nothing wrong in it, right? And because such large sizes is not possible with every technology, and maybe people don't have multiple machines running, they have to always split your part and then join them together. Now, if it's a simple form fit part, splitting the parts in 2-3 sections may not matter, but this is a performance functional prototype. If you split the part, it's likely not going to be usable. In fact, when I was preparing this data, a lot of service bureaus refused to even quote for this part because it was just too big and just too complex for them to even try. And then conventional machining or manufacturing might be cheaper than outsourcing to service bureaus. It'll still be a little bit more expensive than in-house 3D printing because then you have tooling and multiple machining setup, but it's going to take a lot longer of time. Now, if you have to prepare 3 or 4 iterations of this part and you go any other route, you are at least delaying your product by a month. And remember, there's not only one prototype that is required in any subject, whether it be a washing machine or an airplane. You need multiple parts, multiple prototypes. So every day and every rupee that you save on product development by adopting in-house 3D printing collectively adds to a lot bigger saving and a lot faster product development. This is what it would look like if any of the other conventional 3D printing technologies would have to do it. They'll have to split it in 3 parts, and then we get back to where we started from, that we will not get consistently accurate parts. Similar is an example, you saw this in a video, which is my favorite part. This is a base of a washing machine, and there is an internal hollow channel inside here. So an inlet pipe goes from here and outlet pipes comes from somewhere here and somewhere here, and this entire thing is hollow from inside. There is no other way you can build this part cost effectively and time effectively. You'll probably have to injection mold it or at least soft mold it, and it's going to take weeks. But with an in-house 3D printing setup, this is 4 or 5 days of printing, and similar cost dynamics. Despite the fact that this is overall a larger part, this has got some very precise and fine features. If you look at these features where you have 3.5 mm wall thickness, you have internal features, you have ribs and clips that are hanging up. Long story short, fastest way to print, fastest way to create this part is with 3D printing, and fastest and cheapest way to 3D print this part is to have it with in-house 3D printing. Another major benefit of, and this is very specific to fused deposition modeling 3D printing in this machine, is that you can build parts that are hollow from inside. So you can save a lot of material if these are non-functional prototypes. Now, large parts could be everywhere. They could be air conditioners, coolers, washing machines, kitchen equipment, suitcases, lawnmowers, bicycles, automotive fenders, doors. You imagine it, it's all around us. I mean, look at if you have a monitor, look at that. If you have a TV, look at that. If you have a washing machine, look at that. And if you have big parts, 3D printing is this. If you have small parts, 3D printing is still the solution for you. But you have big parts and you do multiple projects a year, this is the solution for you. Some companies and industries that are using our parts, we have industrial machinery equipment, HVAC companies such as Weir and Daikin, sporting equipment such as Decathlon and Yamaha, automotive companies, Nissan, Toyota, in India, Ashok Leyland, Maruti, white goods companies, Whirlpool, LG, Bajaj Electrical, in India, Sub-Zero, agricultural equipment companies, Caterpillar, John Deere, all of these people are using this kind of 3D printing technology to significantly reduce product development lead time. I'm going to show you one video, which is, and then I'm going to show you a couple of Indian examples, and then we can run into some question and answers.
Sub-Zero Group is a manufacturer of luxury appliances, Sub-Zero being the refrigeration appliance, Wolf being our cooking appliance, and Cove being our new dishwasher line. The corporate development lab basically is a mini factory. We're a factory within a factory. We have 7 3D printers. I really enjoy 3D printing. It's my one love in our lab. I can still turn the light on in that compartment and watch those things run and think, man, it's amazing what these things do. And they are really important to us. If you open up a refrigerator, for instance, we make those parts within our lab. Basically, we try to duplicate as many of the technologies and applications that we have in our production floors right within our lab. I was excited about the F770 because of the build size. What we're starting to see is a lot of parts that are just starting to fall outside the build envelope of my Fortis 400s. And so because of that, my Fortis 900 gets overloaded. And also because of that, we end up sending some more of our bigger parts now out to service bureaus. So when I heard about the build size of the F770 and also the price point that was being talked about, I thought, wow, this could be a really nice addition to our lab. The size, the 39 by 24 by 24 is a size that fits us very well. Big's always good. You can make small parts in a big machine, but you cannot make big parts in a small machine. The biggest thing with having the 770 in the lab is that we're going to be able to keep bigger parts in-house. So it's going to eliminate a little bit more outsourcing. Probably 30–40% in savings for us to keep it in-house, which is huge. When you've got product builds coming basically every 6 weeks. 6 weeks seems like a long time, but it's not when you got a large number of component parts that you have to generate, and you got to make sure that you have everything on site and ready to go when that start date is. So we can't miss a beat. Knowing the reliability that Stratasys has shown to us over the 20 years we've been printing with them, I have nothing but confidence that this F770 is going to perform equally as well. We have not seen any major downtime in any of the printers that we've had. They've been supported extremely well. They're made extremely well. I just look at that Fortis 900 that we have, and that thing's just solid, rock solid machine. And we run them hard. Those machines never shut off. We're in there Saturdays and Sundays changing them over because we need the machine time, we need the throughput. And so I don't know, I really don't know where we'd be without them. I did get an actual couple of requests this morning for some bigger parts, and I thought, okay, perfect. Those are going on that machine this afternoon.
So this video shows you how a kitchen equipment manufacturer, and we have similar customers in India as well, is using multiple 3D printers and decided to invest in one more because it was the right product at the right price. Another thing I'd like to tell you, which I cannot insist less on, is the life of a machine. When you buy a system, you wanted to use for a very, very long period of time, and these machines, as you can probably tell from their construction, will last you at least 7 to 10 years. So you don't have to amortize your investment in 1 year, 2 years, or 3 years. You have 7 to 8 years to do this, but most of our customers have managed to get an ROI out of the machine within the first year or two. And one such customer is Ashok Leyland. This company needs no introduction. They are one of the world's largest commercial vehicle bus and truck manufacturer, and of course India's largest. And they claim, and this is their claim from December of 2019, before the mayhem took over the world, is that they have saved nearly 74 lakh rupees in manufacturing costs and about 14,000 days of man-hour utilization in the 2.5 to 3 years that they have had a fused deposition modeling system. And they do everything from mechanism prototypes to complete big cabin interiors, to clutch house development. On and all, they print close to 50 to 80 projects a year, each of these projects being between 1 part and 5 parts. So long story short, the machine runs 24/7. Some of these machines, even during the lockdown, because these machines can be remotely controlled and remotely operated. There are cameras inside the machines, and you can control them from anywhere in the world. Even during the lockdowns, we were running these machines, and you can see the exuberant amount of savings that the customers have experienced. So weeks of work is now hours of work. And remember, when I say 40 hours of printing, it doesn't mean that an operator has to stand there and work the machine for 40 hours. You just press play and walk away. And then once you come back, you just remove the part from the build platform, do some basic post-processing, and it's ready to use. Remember, I told you that there are also ways to improve factory floor efficiencies, which can in turn reduce the cost pressure from the overall product. One such example is from Honda Cars in India, where they have built these large jigs and fixtures, dimension verification jigs, mounting jigs for the front hood, rear view mirror, side view mirror, rear windshield, front windshield, top glass. And these fixtures are running on the line for now 3 years plus. The entire Honda Amaze line does not have a single metal fixture on the line. The entire metal fixtures have been replaced with polymer 3D printed fixtures built out of machines just like this, where the parts are much, much lighter. They're much cheaper to manufacture. They're much faster to manufacture. And most importantly, if a part is lighter, a 30 kg fixture is now reduced to a 7 kg fixture, your factory floor moves faster, your labor efficiencies increase, so on and so forth. So now I'm going to run you some numbers and show you what I've been saying throughout the presentation, that you can build faster parts and cheaper parts. Let's see some more numbers. So I took some sample geometries and did some analysis on them. First one being from a consumer good industry. It's a split AC cover, about 900 mm in length, 1 meter in length, in-house lead time 1 day, outsource at least 3 to 4 days with 3D printing. In-house cost about 19,000, outsource cost at least 35,000. And this is the cheapest outsource cost that you can get. This is not the expensive one. This is hard bargained and negotiated price. Similarly, from the sporting good industry, a bicycle frame, we have a couple of large bicycle manufacturers as our customers. Again, almost a 1 meter part, takes 40 hours to build in-house, takes about 6 days to get it outsourced. Again, more than a 50% cost saving from 30,000 to 76,000, not 76, 76,000. Apologies for the mistake. A car dashboard, 35,000 and 75,000, 2 days and 7 days. And then I come to the most interesting part that I saw, which is a very big, large seat. This is essentially like a baby seat. So, as you know, there are some regulations which tell you that if you have a baby in the vehicle, you need to have a seat strapped onto the car. It takes 100 hours and about 1.5 lakh rupees to build this part in house. The service bureau asked me for about 6 lakh rupees of cost. So that's the amount of saving that you can do both with respect to time and cost by implementing in-house 3D printing. So to cut the long story short and to conclude, FDM and F770 is the best fit when you want to save production time and money. You want to have consistent parts, reduce waste. You want to have first time right parts, yet have the flexibility to fail and have design freedom. You don't want to keep a large inventory. You want to keep improving quality. You want to mitigate supply chain issues. Every common problem that I told you about in the starting of the presentation, 3D printing and in-house 3D printing, more importantly, is a solution for us. With that, I come to the end of the presentation. I hope it was exciting and informative. We can now open the house to questions.
Abhishek, sir, shall we conduct the poll?
Yeah, sure. So I'm going to run a small poll and then parallelly I'll read some of the questions that you have asked in the chat. So please, please answer some of these questions.
So, sir, this poll will be for 45 seconds. I request all participants to cast your votes. We will start the question answer session in 2 minutes. Uh, 20 more seconds. Okay, we will be closing this poll now. Now we will be taking a quick feedback poll.
Okay.
Yeah, 45 seconds for this one. Yeah, 10 more seconds. Yeah, we'll be closing this poll now. And the upcoming poll is for whether Altem should get in touch with you. 15 more seconds. We'll keep this poll on. Abhishek sir, yeah. Now I will keep one poll open for one minute, but we can start with the question and answer sessions.
All right. So I saw some really interesting questions in the chat, and I will read it. First question is from Mr. Abhinav Daga. Abhinav, please, if may I request you to turn on your mic uh, and uh, and ask the question directly. I want to make sure I understood the question correctly.
Yeah, we have now provided permission to unmute. So you can unmute yourself. No issues.
This is by Mr.
Hello.
Abhinav Daga. Yeah,
Yeah.
Yeah, hi Abhishek, how are you?
very well, sir. How are you?
Yeah, good, good. I've actually attended your previous events also. When you were also talking about the biorobotics and other things
Okay,
on YouTube channel.
okay,
But I couldn't attend it live, of course. But yeah, I was just
okay.
going through all these things. So it is interesting that you guys are giving so much in-depth knowledge about the industry.
Yeah,
But when I was just while you were discussing, so the contradiction is, see, I'm an 3D enthusiast basically, and I would want to set up a service bureau in the country,
okay.
probably in Bangalore or in Andhra region, given the government's quite encouragement towards this sector.
Yeah,
But now, when you mentioned that there is a confidentiality clauses that has been imposed by the Indian partners for printing,
yeah,
and when it comes to service bureaus, maybe abroad, of course, I'm not sure whether they're in touch with few of the service bureaus in the country. But so why are they not selecting the Indian service bureaus at one point of time? One thing. Second thing is that when there is definitely a demand, that means if they are going abroad for some kind of service bureau sectors, so why are not they selecting the Indian bureaus? That is one part of it. And how, when you also mentioned that in-house and outsource cost, right?
yeah,
So in-house cost is quite less what you are shown in the analysis in the presentation, but when
yeah.
you show the outsource cost of these service bureaus, so the difference seems to be too high. I
Yes.
doubt the Indian service bureaus would have that kind of a difference actually. So that's why I doubt actually when you mentioned that.
Okay. So just to reiterate, Abhinav's question is, first he's asking why are Indian companies going to overseas service bureaus? Um, the second question that he's asking is that he's a bit unsure of whether the cost difference that I am projecting is not as much as probably what's the reality of the Indian market. So first thing, not all Indian companies are outsourcing to global service bureaus. In fact, uh, there are some very good Indian service bureaus that many of these big companies are outsourcing to. In fact, even customers of ours who have not one but multiple machines are still outsourcing uh, uh, to service bureaus because of demand versus supply gap. So they have two machines, but they have work enough for three machines. I don't say that always your data will leak, but there are several. I mean, we come across at least 1 to 2 instances a month where we see data getting leaked, and even the largest service bureaus and the smaller service bureaus, it ends up happening. Uh, so companies are becoming more and more conscious of what they want to send outside and what they don't want to send outside.
Of course, of course.
Traditionally, it was too expensive to own big, large size capability machines for everybody in house. They used to cost in 3 to 4 crores. Now it costs about 60, 70, 80 lakh rupees. There are cheaper 3D printers also,
Mm-hmm.
but the big one, the big bulk, the 1 meter ones, traditionally, if you want a machine, you need to go for a machine called Stratasys F900, which
Mm-hmm.
starts at 3 crore. Now
Mm-hmm.
you get the same size capabilities and same geometry capabilities for about 70 lakh rupees. Okay.
Mm-hmm.
So you may not get some of the exotic materials like aerospace materials or medical materials, but size and geometry wise, it's the same platform.
Mm-hmm.
Now, will this machine be something that everybody will buy in India and service bureau market will get killed? No, not at all. This this platform is for the people who do large quantum of work. So, for example, you are doing 20 of those split AC covers in a quarter, or say 50 such parts or 30 such parts in a year, then this machine is for you, because then the amount of money that you will save by keeping it in house will, will be higher than the cost of the machine itself, or you will be able to compensate the cost of the machine and get your ROI quicker. But there are still companies in India who do maybe 5 or 6 parts a year, 6 to 7 parts a year, and the journey for them is even more difficult because these are the people who are not able to set proper confidentiality agreements, proper rate contracts, this and that with service bureaus. So if and so even the service, and that's the whole market that the service bureau are trying to capture, is to capture people who cannot or do not need in-house 3D printing. A lot of service bureaus and some of the major established ones are also showing a large interest in this particular 3D printer that I showed you, because it's cheaper and easier to operate than any other industrial technology that is available in the market. That's one thing. Second thing, to answer the question, the cost that I gave you. So if I say the split AC cover will cost you 20,000 rupees in-house, and if you outsource it, it'll cost you 70,000 rupees. That are costs from Indian service bureaus, not global service bureaus. Okay. The technologies that Indian service bureaus are running, if for them the in-house cost will still be 20,000 rupees, but they need to charge, labor cost, they need to charge profit, they need to charge bank interest, that, because that machine has been brought to make money, not save money. When a company buys a machine for R&D, they buy the machine for to reduce the product development of time, which in turn is larger money. For example, if an internal company's product gets delayed by 3 months because prototypes are not ready, imagine the amount of cost they are going to.
No doubt.
They are going to. So there is a balance always in the market. But typically, service bureaus are charging about 3.5x. There's nothing wrong in it, right? Because they have to make their money back. But today there is a solution available where you can buy a relatively less expensive machine and get a faster ROI without breaking the bank in-house. And then you solve all the other problems as a counter effect of it.
But right. when you mention it as, in terms of that, what you answered it, thank you for the answer at first. But what I want to understand is, like, if I want to really set up a service bureau, how would you encourage me on that? Basically, that's the whole point actually.
How will I encourage you to set up a service bureau is by telling you that this particular solution, and of course we can run on the specific numbers, will make you give your services at least a 30 to 25% cheaper price than what is currently available of equal quality in the market. That's what I'll tell you. Sure. If you have to set up a large format setup, the machine cost you could still buy. Even if you buy an alternative technology, industrial technology will almost be the same. It's about the operational costs and the material costs. So with this machine, we have packaged the material in a way that the material is about 40-45% cheaper than what it costs traditionally, and there is almost no ancillaries.
But this material, what you have is only from Stratasys, which is locked.
Yes.
So, correct, right?
Yes. Yeah. See, of course, there are large format printers available in open source format also. Most of these parts you'll not be able to make on those machines, as you can probably tell from the geometry, or at least not straightforward. And then when you start doing iterations over iterations, or when the process starts to get complex and bigger, then you lose the money that you're actually on paper you are making, right?
Sure.
Yeah.
Sounds good. Thank you so much.
That answers your question.
Yeah, thank you so much.
There is a few more questions. I'll take it up quickly. One of the question is, was that frame cost 70,000 or 70? No, it was a typing mistake. It was 70,000. 70,000 for outsource, about 20,000 for in-house. One more question from Mr. Abhinav. Am I including design cost also? No. So this is a scenario where the design will come from the customer and the service bureau just prints it.
Sure.
There is one question from Dr. Senthil Prabhu. Is this technology applicable for mass production? It is not. For mass production, we have two different types of technology. One is a powder bed fusion technology, and one is a photopolymer based technology called SAF and P3 respectively. We'll be doing separate sessions on them. But these are technologies where, for smaller components though, there are no large format solutions available there. But when I say smaller components, I could mean a 50 by 50 component to a 250 by 250 component. You can almost do 10,000 parts a year. Then there is a question, is raw material to be used from Mr. Suresh Cladon. raw material to be used is engineering grade thermoplastic. Are you? Can you? One more question that Nilesh asks. Can you share the details of the raw material cost? I'll give you a simpler answer to that question. Uh, Everything put together, raw material, all other ancillary accessories, print heads, for example, the cost per cubic centimeter comes to around 24 rupees per cubic centimeter, which is one of the cheapest in the market. One of the questions that Mr. Prabhu Therani asks is that tolerance and dimensional accuracies for repeat item 100 microns tested to 95% uh, repeatability scale. We have a 30-page reliability and repeatability study published. There is a question from Sivaraman Vijayakumaran. Have you done any components from aerospace? Lot of components we have done for aerospace. We have done components and we have customers where these are prototypes like for wind tunnel testing, all the way up to components which are inside ISRO's satellites, which are aluminium components replaced by plastic 3D printed components of equivalent material, ranging from 50 mm by 50 mm parts to 1 meter by 1 meter parts. There are parts on HAL aircrafts and helicopters. There are parts inside DRDL missiles. There are parts inside the ISRO satellite. There were even a few printed parts in that moon rover that crashed. So long story short, we have done a lot of work for aerospace. Another last question that I will take was, can you do sand printing? We don't have sand printing, but you can use these polymer printed patterns as patterns for sand casting. And that's actually one of the oldest established applications of 3D printing, is that you print the pattern and then make a sand core out of that pattern. And a lot of both commercial automotive as well as aerospace and defense industries are using it. I think I will also going to leave the email ID on the screen. You can, if there are any questions that are unanswered, you can just write to us at inquiry@altem.com. And once again, thank you so much for interacting with me so heavily and listening to my presentation. Back to Mr. Ramesh for the conclusion. Hello, Mr. Dhananjay or Mr. Ramesh, one of you could.
Yes, sir. Yes. So you can display the contact details on the screen, or else you can mention it in the chat box. It will
I
be
have
easy
left.
for
I have left it in the. 1 second. Sorry. I have left it in the chat window.
Yeah, now it is visible, sir. Yeah.
And I'm also leaving the phone number. So write to us, call us.
Yes.
We'll be happy to sit with you one-on-one and discuss your specific use case.
Yeah. So I request all the participants to note down the email ID and mobile number.
Yeah.
Okay. Sir, there is one query. Can we get a copy of presentation?
Yes, you will get a version of this presentation. We'll email it to you.
Okay. Okay, sir. So then, shall we conclude, sir? Anything from your side? Abhishek, sir?
Yeah, we can conclude.
Okay. Okay. Thank you so much, sir. I thank all the participants for joining the webinar, and I thank Abhishek, sir, for conducting such a wonderful webinar. Thank you so much.
All
Yeah,
right,
we'll be
everyone.
concluding.
Stay safe. Bye-bye.
Bye. Bye.